Hi class, how are you today? Oh my. Why would you even tell me that? That's horrible. Let's just move on. The learning target for today is to divide monomials. So last class we multiplied monomials, now we're going to divide them. To start this, we're going to have to learn some new properties of exponents. Alright, so in the last video, we learned that when you multiply variables with the same base, then you add the exponents. And if you raise an exponent to another exponent, then you multiply the exponents. Now we're going to learn some more properties of exponents. So if you have x to the m over x to the n, two variables with the same base, the same variable, they're both x's, and you're dividing them, then what you do is subtract the exponents. So this is going to be x to the m minus n. An example of that could be x to the fifth divided by x squared would be 5 minus 2 is 3, so x cubed. So if you ever have a variable raised to a negative exponent, then what happens is you need to bring it into the denominator. So essentially it's the reciprocal. So you would say 1 over x to the m. So all you do is you get rid of the negative and then bring it from the top to the bottom. If it was already in the bottom, you would bring it back up to the top. So you just put it in the opposite spot that it is in the fraction. An example would be x to the negative 5 would be 1 over x to the fifth. If you have a fraction and the entire fraction is being raised to an exponent, everything in that fraction is being raised to the exponent. So x over y to the m is the same as saying x to the m over y to the m. Now you wouldn't be able to simplify those anymore because x and y are different bases. So an example of this could be x over y to the fifth, which would be x to the fifth over y to the fifth. If you ever have a fraction raised to the negative exponent, once again, just like having the actual thing raised to a negative exponent, it's going to be the reciprocal. So what happens is the negative essentially tells you to flip everything. So everything on top goes to the bottom and everything on bottom goes to the top. And then raise everything to that exponent. So in this case, that would become y to the m over x to the m. We flipped it, x went to the bottom, y went to the top, and then we raised everything to the m. An example of this would be x over y all raised to the negative fifth would be y to the fifth over x to the fifth. And the final property is x to the 0. So anything raised to the 0, except 0, is always going to be 1. So no matter what the number is, or variable, except 0, if it's raised to the 0 power, is 1. So an example of this, 52 to the 0 power is 1. If you had x to the 0 power, that would be 1. Anything to the 0 power, always 1. So let's start off with the first example. So this is very similar to multiplying monomials, where deal with the numbers as you would normally deal with the numbers, and then subtract the exponents for each variable. So 20 divided by 4 is 5. And if it doesn't divide out evenly, you would reduce it some way. But in this case, it divides out evenly, so it's 5. Now, we have x cubed divided by x. So remember, x by itself has an exponent of 1. So 3 minus 1 is 2. So x squared. Then y to the 5th divided by y to the 2nd, 5 minus 2 is 3. So y cubed. In this one we have 3x cubed over 7 all squared. So like I said, you have to square everything here. So that exponent goes to everything there. So first, the numbers you raise to the exponent. So 3 squared is 9. Seven squared is 49. And then x cubed squared, that's where you multiply the exponents. So 3 times 2 is 6. So x to the 6th. And these numbers can't reduce at all, so leave them just like they are. In this problem, we have x to the 5th times y to the 0 power over x cubed. So, remember, anything to the 0 power is 1. So, in this case, if this is to the 0 power, it's 1. So we say x to the 5th stays x to the 5th over x cubed. Those two stay. Y to the 0 just becomes 1, and anything times 1 is itself. So this pretty much just disappears because it's just 1. And then we have to simplify this. 5 minus 3 is 2, so this is going to be x squared. In this problem, we have two negative exponents. So first thing you want to do is get rid of those negative exponents. The way you do it is by bringing it to the opposite part of the fraction. So if it's on top, you bring it down bottom. If it's on bottom, you bring it up top. Only the negative exponents. So we make our fraction, and then we say what goes on top, what goes on bottom. X to the negative 5th, negative means bring it down. So x to the 5th. We made it positive and brought it down. Then y to the 4th. It's positive, so it stays on top. So y to the 4th. Then z to the negative 2, it's negative, and it's on bottom, so it needs to move to the top. So z squared. You make it positive, and then you move it from the bottom to the top. Now they're all different variables, so we can't simplify anything anymore. Alright, here's a big one. So we have numbers, and we have x, y's, and z. So before we do anything else, Let's move the negative exponents. So here we have a negative x to the negative 3, here we have z to the negative 5. So those things will have to move, and then everything else stays where they are. So 5 is not raised to an exponent, so it stays 5. Then x to the negative 3 will move down bottom. And negative 20 will stay negative 20. So we have an x squared here, but we also have an x to the third, because this x squared stayed down bottom. X to the negative 3 became x to the third on bottom. Got rid of the negative, bring it down bottom. We'll have to deal with this in a moment. Now, the y's are both positive, so those stay exactly where they are. Y to the fourth and y to the seventh. Then z. Z to the negative fifth gets brought up top and becomes z to the fifth. Now we have to do some simplifying. So let's deal with the numbers first. 5 over 20. 5 over negative 20, really. So you can't divide those straight out, so reduce them. 5 and 20 can both be divided by 5. 5 divided by 5 is 1. And if it's just 1, you don't have to put it unless it's the only thing on top. So 5 becomes 1. Negative 20 divided by 5 will become a negative 4. So 5 over negative 20 became 1 over negative 4. Then the x's. We have two x's both on bottom. Since they're both in the same spot, those are multiplying, so you add the exponents. So that gives us x to the 2 plus 3, which is 5. Then the y's. Y to the fourth divided by y to the seventh. Subtract the exponents. 4 minus 7 is a negative 3. Since it's negative, it goes down bottom. So y to the 3, or y cubed. And then z to the fifth, no other z's, completely alone, stays z to the fifth. One final thing, this negative, it doesn't matter where it goes, if it's down bottom, on top, or even in front of the fraction. As long as there's only one of them, it's perfectly fine. Alright, here's the last example I'm going to do. So, say we have this here, and it's all being raised to the negative third. So, two things happen. First, you flip it, and then you raise everything to the third power. So first, to make it easy, let's flip it. So we've got 2x y to the fourth over 4x squared y, and that's all being raised to the third. So all we did was get rid of this negative here and flip everything. Now, we're going to raise everything to the third power. 2 to the third is 2 times 2 times 2, which is 8. X to the third power is x to the third, or x cubed. y to the fourth to the third, multiply the exponents. Y to the 12th. And then that's going to be over 4 to the third, which is 64. X squared to the third, multiply the exponents. 2 times 3 is 6, so x to the 6th. And then y to the third, y to the third. Then we simplify what we can. 8 over 64, both of those can divide by 8, and that would become 1 over 8. So again, you don't have to put the 1 on top because there's nothing else there, because there's going to be other stuff there. Then x cubed over x to the 6th, subtract the exponents, gives you x to the negative 3, so that means it goes down bottom, x to the third. Then y to the 12th over y to the third, subtract the exponents, 12 minus 3 is 9. Y to the 9th. It's positive, so it goes on top. When you subtract the exponents, if it's positive, it goes on top. If it's negative, it goes down bottom. So that's our answer. Y to the 9th over 8, x to the third. Alright, that's it for the lesson. Now time for the sponge. Alright, here's the sponge. 3 questions. Simplify each expression. As per usual, the sponge activity, you have to at least attempt. Don't just write the problem, you have to attempt something for an answer. But if you get all 3 right, you get a bonus point on the next test. Alright, so that's it for this lesson. Once again, please make sure to take notes over the entire lesson and attempt the sponge, and submit your notes and the sponge to eBackpack. Please don't wait until class. Have a good night.